All right, folks, here on the main stage, we're going to move into a presentation from Esri. I see a bunch of geomatics people in the room here. So with that, I'll hand it over to Robert Harris from Esri Canada to take us through his material.
All right. Can you hear me okay?
Yeah, we sure can hear you well. We'll have someone monitoring the chat so we can bring those questions forward. And then in the room, we'll have a couple of mics. So we'll let you know if that comes along. So we're all set here.
Perfect. All right. Let me just hit start here and we'll get going. All right. So welcome, everyone. I'm so glad to have been invited back here today. Some of you may remember me from last year's summit. My name is Robert Harris, the NextGen 911 Data and Solutions Manager with Esri Canada. Had a different title last year, but happy to be back here with my new title this year. Last year, I gave a presentation that laid down some of the foundational pieces of GIS for NextGen 911. And today, I'd like to explore a couple more concepts with you. First, I'm going to give a really quick refresher on what the heck NextGen or Next Generation 911 even is. Just in case you weren't here last year, or like most of us, you've got 1,001 things going on and it's completely slipped your memory. When I've got that recap out of the way, I'll explore some of the things that have changed in this space over the last year, and on some of the changes that have been made in some of the GIS for NextGen requirements. Then I'm going to get into the meat of today's presentation and talk a little bit about the phased approach concept and how that could help Northern Indigenous rural communities or any small local government really to meet its next-gen GIS requirements. I'm going to talk a little bit about open data and how that can help satisfy these requirements. And then finally, I'm going to close out with a couple of next steps on how you can join the national conversation that's going on right now around GIS for NextGen. My hope is there will be ample time at the end of the presentation for a couple of questions, as I know there were many last year and I want to make sure I can answer kind of as many of those as I can. So if you're asking what the heck even is, NextGen 911, really what it is, it's the transition of 911 from its current analog system to an IP-based system. The current system was built in the 90s and was really helpful when everyone had that giant massive phone in their kitchen wall. That phone never left. We always knew its location. We are moving to a system that is much faster, more resilient, that can allow voice, data, photos, videos, and text messages, all to kind of flow seamlessly from the public to 911. So NextGen 911 is really that digital IP-based system that's going to replace all of the analog technology that's been in place for a couple of decades now. It is fully mandated by the CRTC. And the good news for the GIS folks in the room is that GIS is the backbone of kind of how some of this magic is going to work. So I've got a diagram on your screen here, and I know it can be a little intimidating. Don't worry, there's no pop quiz at the end of the day today, but bear with me and I'll walk you through it. So you see in the middle there a term called EZINet. That's the Emergency Services IP Network. And you can really think of that as like the cake. This is the final product that is made up of a bunch of whole little bits or ingredients called functional elements. So functional elements, they're the little boxes. They're outlined in a dark green color, and you're kind of in the middle and leftish of your screen. So I also want to draw your attention to the little globes. So those little globes represent authoritative GIS data, and as you can see, they're used in multiple places inside this EZINet cake. GIS data flows over the blue lines, and this whole NextGen EZINet ecosystem relies heavily on spatial queries to do its magic. So I'm going to give you two examples, and I'm going to flow through this diagram really quickly. And these examples are on how GIS data can be used. So I want to take you along the top of the diagram. So let's say you're an originating network provider. Let's say it's a telephone company, and you have a new subscriber at 123 Main Street. You want to make sure that the address your new subscriber is giving you is valid. So you will take that address, you'll make a query against the functional element called the list or location information server. The list takes that address, feeds it to the LVF for location validation function to do a spatial query using that GIS data to validate and confirm, yeah, 123 Main Street is a valid address. Your subscriber is good to go. Another example is a 911 call that comes in, again, from originating network, like a telephone company, cell phone call. It will first encounter that little black box at the bottom. We call that the border control function. That is the functional element that I like to think of. If you think of those guards with the really tall hats in front of Buckingham Palace, keeping us commoners out of the palace, that's what it's like. Its job is to keep those rogue and scary internet things outside of the ESRI-net. So once the call has gotten past the guards, it will hit what's called the ESRP, or Emergency Services Routing Proxy, which takes the coordinates of that cell phone, does a spatial query against the ECRF, the Emergency Call Routing Function. The ECRF will take those coordinates, figure out where it needs to route that call, passes that back, and then that call gets passed on to our public safety answering point. We call those PSAPs. Those are really those 911 centers, and it's whoever the center is identified in a polygon layer in the GIS data. And the final direction in the data flows is that far right. It's that blue line that's going down from the big globe, and that is the more traditional route for GIS data. So GIS already use that our PSAPs in their integrated mapping, their CAD, which is their computer-aided dispatch display to figure out where the emergency vehicles need to go. So all of this data is managed in a document called the NINA standard for NextGen 911 GIS data model. This document is your guidebook for ensuring your GIS data is compliant to spec and what we are commonly referring to as public safety grade GIS data. If you take a peek at the dates on the front of the document, you're going to notice it's been very recently updated. This is what we're calling the version 2 of this data model, and it was approved and published just a few weeks ago. And I'm going to go over some of the content on what's changed in this document. So again, this document is the model for storing GIS data to support NextGen 911 and describes how your data must be structured in order to interact with that ESRI-net system. The version 2 was modified, if you were familiar with the previous version, and it has now included some what we've called Canadian concerns. So this was a US model. We've now added some Canadian concerns to make it more North American friendly. And you're probably going to spot some of those in the table in the bottom half of the slide. So I want to draw your attention to the top level of the chart, which groups data into one of 3 categories. I'll go over what the difference is in just a second. But before we get there, I want to go over those few layers that are under the required column. So some of these are fairly common data sets that many local data authorities already have across the country. They're things like your road center lines, your address points, your PSAP boundary, which that's the 911 center, and your other emergency services boundaries. So things like police, fire, ambulance, etc. And something new, which is called the provisioning boundary, which is essentially a polygon that says, if there's data issues inside this polygon, go to organization X for updating. And I also want to draw your attention to the parentheses under some of the strongly recommended. You're going to see mention of something called A1, A2, A3, which was part of our alignment and Canadianization to remove references to a whole bunch of US heavy concepts like state, which we don't have in Canada, or county, which we do have in Canada, but there's large swaths of the country that have no county or equivalent administrative level. So now that we've talked a little bit about those, here's what those 3 columns actually mean. So required layers are exactly that. They are those layers which are essential to have in order for those functional elements to process and route a 911 call. 2 of those functional elements, we saw them on the slide before, the ECRF, the LVF. ECRF is the brain that will do the point and poly spatial query. And the LVF is something, to do that location validation for that subscriber before the call. And the SI, which you would have saw on the slide before, is basically how you're feeding the data in, and then it goes out to the functional elements where it's needed. Strongly recommended are layers that can help those functional elements, aren't necessarily a must for call routing, or they're just helpful to have for folks that are answering a call. And the recommended layers aren't used by the functional elements at all. They are purely to help with your map display, to kind of help give you better situational awareness if you're trying to, take and dispatch 911 calls. So, background out of the way. Now that we've talked about data model, I'd like to talk about one other NINA document. This is NINA's INF 028.2, or as it's more commonly known, GIS data stewardship. So I don't have a fancy graphic for this one because this document is actually still going through NINA's, which is the National Emergency Number Association. They're a US-based organization that makes standards for 911 for North America. They have a very rigorous approval and accreditation process. So that document is currently in what's called public review. It's there for another 10 days, but it is stable enough that I can kind of discuss some of the subjects and approaches it talks about. If you're interested in getting a full copy, reach out to me afterwards. I can direct you to a web page where you can download the latest copy. And up until the review period closes, you can even recommend specific revisions to the document if you feel there's something lacking in it. So the document talks heavily about data management, more so than the actual data model document, which is table structure, like your field width needs to be this long, can contain this many characters, et cetera, et cetera. In its current form, it's a little over 100 pages of reading. So I've done my best to kind of distill some of the key concepts in my next few slides. I highly recommend that if you are a data authority that is maintaining any sort of next-gen supporting data, that you do give it a read. While it does offer specific guidance for the different required layers, it also has this overarching theme, and that theme is this phased approach to data management. I think this approach is key. When I proposed this presentation topic, I wanted to make sure I could frame this phased approach to how those smaller communities, northern communities, wherever, on how they can start to bite off some of these next-gen requirements. And I do think that this phased approach is key to it. So I've summarized the approach into kind of 3 phases, or not 3 phases. I've named them 3 different, summarized into 3 different themes, and that they are assessment, refinement, and then the ongoing maintenance. I've avoided numbering these phases, as depending on your organization and your already level of readiness, your path may look a little different, and some of these steps may be repeated. So every phase does have distinct activities and outcomes. So I've broken them out a little bit in my next couple of slides. So we'll get right into it. So first phase, assessment, is really about starting with a self-assessment of your current roads, addresses, and emergency service zone data that you may have. Determine where the need is, where the gaps are. Do you have a complete border-to-border coverage for the area that you're responsible for, or do you have nothing? You can start by creating an inventory of existing data sets that could contain relevant attribute information. Take a peek at what their source may be. Is it a neighboring municipality, province, or territory? Some provinces have provincial road networks. They may not have all of your local roads, but at some times it's a good place to start. Is there some sort of provincial or territorial addressing authority? Is it a federal data source? So something like a national initiative from StatsCan or similar. We know that many private companies and vendors offer their own data solutions that they've either collected, privately or digitized from some sort of remote sensing means. And of course, our friends open and crowdsource data. So we know that there are very rich data sets out there that can help us kind of satisfy some of these next-gen requirements. So with that bit done, we then look at identifying ownership, data maintenance frequency. So if you're using data providing from this person, but they only update it once a year, is that good enough for you, and your organization for what data you're providing? And then the final step of this phase is really to start doing a little bit of the heavy lifting and starting to populate some of those core attributes mentioned in the data model document, doing those core attributes on this data for some things like street names, ranges, and things like that, if we're talking about road center lines. The next step in the NINA phased approach is refinement. So this is where a lot of grunt work starts to happen, and likely where you're going to spend the most amount of your time. It's where we continue to refine those necessary attributes required for NextGen, and for NextGen to work properly and to really start to validate the data. It is essential for this stage that you connect with whoever is your ESRI provider. We know large portions of the country are Bell or Sustel or Telus, or depending on where you're living, and you will absolutely need to connect with them to make sure that you can validate whatever data you have ready against any existing data in their alley or master street address guide databases. And this is essential to ensure that no existing subscribers and their databases will fall out of the system in error once they've transitioned to your new GIS data. This is also the stage, unfortunately, where you're most likely to find any data skeletons that have been hiding in the closet. I remember doing this step in my previous role with the province of New Brunswick, and it's where we started finding, ghost civic addresses from 30 years ago, pay phones that had been given civic addresses and had been demolished for more than a decade. They all kind of bubbled up to the surface when we started doing some of this kind of validation. This is also where it's super important to know what your data source is, because that could help with understanding where any data errors and discrepancies may be. And finally, at this phase, the layer must be able to properly support the LVF and ECRF functions. So the attributes that are required for those functions must be filled in. So this includes any attributes that weren't included in the first phase. So especially things around the administrative level. So those local area polygons. And this phase is where you're really going to start gaining and building trust in your data set. And from experience, this phase takes way more time than you think it will. And the final approach, the final phase in the approach is maintenance. So at this point, the layer must be able, whatever layer you're working with must be able to properly support the LVF and ECRF functions. So the final attributes that are required for those functions must be filled in. So these are things that that aren't commonly found in most data sets. These are discrepancy IDs, these are GUIDs, service URNs. Once again, you're going to need to work with your ESRI provider to figure out what those are so that you can get them into the data. And this is where your data will finally be NG ready and NINA compliant. The hardest work at this point will now be done, but now you're going to have that chore of the ongoing daily maintenance to make sure your data set stays up to date and to spec. So I also want to take a moment, question we get a lot. How can I leverage open data? Can I use open data? And depending on who you ask and in what mood they are when you ask them, you're going to get a kind of answer. But I'll answer it honestly and outright. Yes, you can use open data. There are many communities in this country who have little or no GIS data to satisfy the needs that are coming for NextGen 911. In open data, it can present itself as a means to help address this gap. I am a strong believer of something is better than nothing principle, which in this case, the nothing would be starting your GIS, 911 GIS layers completely from scratch. However, there is a difference between, validated open data from an authoritative source versus crowdsourced open data. That crowdsourced data may not be authoritative, can have little to no metadata, and maybe have inconsistent quality and coverage. Can you use it? Yes. It can provide a good starting point for communities so that they can then refine it, validate it, and then subsequently mark it as authoritative for delivery into the NextGen system. Those ALI and MSEG record comparisons become super critical then with helping to validate that data, building the level of trust, comfort, and making sure you have the right level of accuracy with this data set. And at the end of the day, when this data is being provisioned into the NextGen system, you as the data authority providing this data are giving it your stamp of approval. You're saying, yes, this is what I want to use to make sure that ambulance gets to my house. So if you're prepared to give it that stamp, then you're good to go. And I also wanted to give a small plug to our Esri Canada Community Maps team. If you're small and you don't have your data 100% ready, I know some of the work that they're doing when they onboard their communities is help kind of organizing and field mapping that data into a schema that is 911 friendly. It's not quite the 911 model, but it's very close. And I know our community maps advocate, Alia, is also giving a presentation after mine in one of the breakout rooms. So if you want to learn more about them and their program, which is fabulous, and then you get to hear its mission and mandate, I recommend you head over there in a couple of minutes. So before I open it up to questions, I wanted to leave you with some actionable next steps. First, the best time to start getting ready for NextGen is yesterday. The second best time is today, especially if you have to start from scratch, have a start from scratch scenario. It is never too early to start investigating what could already exist to help you get started on the right foot. Next is have a chat with your ESRI provider, especially if you've already received your new 911 service agreements. The sooner you have data available to validate, the sooner you can get into the queue to be validated and transition to NextGen. Remember, these ESRI providers are still building their ESRI cakes. They're doing it right now, and it might be another year or so before they're ready to validate. But the closer we get to our go live date for NextGen 911, which is 4th of March, 2025, and for those that work in this space, that is nothing away. The closer we get to that go live date, those ESRI resources are going to be swamped trying to onboard PSAPs and other data providers. So the earlier you can get into their queue, the better, so they can properly plan out their resourcing. The next one, and I cannot stress it enough, is talk to your neighbor. Ask them how they're doing in their NextGen prep. Start sharing your data sets so that you guys can make sure that they're aligned, that they can stitch together once they're delivered to the ESRI. I know that sometimes boundaries can be a sore point, but 2 points to remember: your 911 boundaries do not have to align with any specific legal boundary, but they do have to align. So if there's a street or subdivision or something on the border of you and your neighbor, you'll need to agree on some sort of compromise, or else any 911 calls that happen within that disputed zone could be misrouted or route to the wrong PSAP. And there's not a single mayor or warden, council, legislature, chief, or whomever who wants to be on the news for not being able to properly deliver 911 services over a boundary dispute. And the last piece I have, please join the conversation. We have a national working group, the Emergency Services Working Group, and more specifically TIF 92, where we are meeting regularly to discuss GIS for NextGen, figuring out how this is all going to work across the country, sharing great ideas, and doing some fantastic problem solving on some of these core problems that we all seem to have with our data. If you've got questions, we've likely got the answer in that group. I co-chair that initiative with my colleague Rob Darts from Vancouver. And if you want to join, joining is super easy. You just need to send me an email asking to join. And my email is right on the screen there. So with that, I'd like to thank you so much for listening to me today and listening along as I try my best to explain what can be some highly complex concepts for some. And I'd love to open the floor to any questions you may have in the few moments we've got left. Thank you.
Thank you very much for that. We do have some microphones in the room. If anyone has a question they would like to pose from the physical room here. Otherwise, online, we have people monitoring that. I don't see any questions in that queue. So I think with that, we'll say thank you very much for your presentation. I can see around the room, there are a few people here involved in that E911 progress for Yukon, at least the folks I'm familiar with. So the discussion is, I think, falling on the right ear. So thank you for your time.
Awesome.
And we'll look forward to continuing the discussion with you. Bye for now.
Thank you so much.